Good evening. This is my project. I just want to prelude this by saying I've been trying for the past 6 hours, watched resources, on my own research on the internet, and I still, I just I don't know. I can't figure it out. So I'm just gonna go over the steps of how in a perfect world it would look if it was correct, and then I'll also show my steps of what I got so far and things of that nature. So just a quick overview of CRC. CRC is a non-cryptographic method for checking the integrity of data. It's commonly used to detect unintentional bit errors in transmitted data, helping to ensure that the data we receive is the same as the data that got sent. In secure programming, data integrity is crucial, and CRC is a simple but effective tool that helps us maintain that. So starting with the incorrect version of the code, in this version we're simulating a network that sends and receives packets. Each packet has a counter and a checksum. The checksum is calculated using CRC and is meant to validate the integrity of the packet when it's received. The only problem is that with the incorrect version, during the receiving process, we intentionally modify the packet's counter value, introducing a bit error before performing the CRC check. This causes the calculated CRC to mismatch the checksum attached to the packet, therefore failing the integrity check. Now, since the packet's corrupted, the program outputs a message saying that invalid packet is detected, which I have a lot of those. Now, in a perfect world, the correct version of the code, you use that to avoid any modifications to the packet's data after it's sent. When the packet is received, it calculates the CRC based on the original counter value, which should match the checksum that was initially sent to the packet. In the correct version, as I mentioned earlier, since the data hasn't been corrupted, the calculated CRC matches the packet's checksum, meaning the integrity check passes. As a result, the program increments the counter successfully, and no error message would appear. That would be the correct behavior when doing this, opposite of to what I have done thus far. So when comparing the two versions, one can see how even a small error in data transmission can prevent the packet from being processed correctly. CRC is amazing at detecting these kinds of unintentional errors, and that's essential for maintaining reliable communication in a network environment. However, it's important to also note that CRC, as I mentioned earlier at the start, is a non-cryptographic method. While it can detect simple bit errors, it doesn't provide the same level of security as cryptographic hashes such as HMAC, which also ensure authenticity and protection against intentional tampering. So to wrap this video up, in summary, the corrected version of the code shows how CRC can maintain data integrity by verifying that the data received matches what was sent. This practice is fundamental, as was also laying the foundation to secure programming, helping ensure the accuracy of data and preventing unintended changes from impacting the system.